Okay, today we're going to talk about absolute value functions. We want to start with our parent function. Here it is, y equals absolute value of x. To graph this guy, the best thing to do is to make a table of values. So what we're going to do is we're just going to choose values of x. So I'm going to choose -2, -1, 0, 1, and 2. And when we plug these in, the absolute value of -2 is +2. The absolute value of -1 is 1. Absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. Alright, now what this does is it gives us these 5 ordered pairs. The first one is -2, 2. Then we have -1, 1, 0, 0, 1, 1, and 2, 2. And you can see these are all plotted here. Okay, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Here, if you notice, we have an axis of symmetry. This line created at x equals 0, where the value of x is 0, kind of makes a mirror image. The right side looks exactly like the left. Alright, now we're going to look at moving these absolute value functions. Our general form is here, y equals a times the absolute value of x minus h plus k. H and k are always your vertex. So whatever number here goes here, whatever number's here goes here. Now I want to caution you guys, whatever you see, when you see x minus h, what goes in here for h is always going to be the opposite of this. So if you see x minus 4, it'll be a positive 4. And if you see x plus 4, this will be a negative 4. Okay? Your axis of symmetry is always going to be x equals whatever this h is. Alright? Now, your k here is a transformation either up or down. It's vertical. Your h is going to be left or right. So it's your horizontal transformation. Your a is going to be a stretch if it's greater than 1. It'll be a compression if it's between 0 and 1. And if you have a negative in front of the a, it will be a reflection over the x-axis. So instead of being tall and skinny here, or wider and flatter here, you'll end up with something that opens down because it will be reflected over the x-axis. Okay, we're going to look at graphing this function, y equals the absolute value of x plus 5. Now, let's start with our h and our k. Since there is nothing here with our x, our h is 0. Since we have a 5 after the absolute value symbol, we know that our k is 5. This tells me that my vertex is going to be the ordered pair 0, 5. Right? That means that I'm going to have no horizontal shift. I'm not going to move left or right. However, I will have a vertical shift of 5. I'm going to move up 5. So let's graph our parent function first. -1, 1, -2, 2, -3, 3. So the left side looks like this. Of course, you'll use a straight edge. And the right side, 1, 1, 2, 2, 3, 3, looks like this. Alright, and here we can label this y equals the absolute value of x. Alright, our new vertex is going to be at 0, 5. That means I'm going to shift every point up 5 units. 1, 2, 3, 4, 5. Here's my vertex. Alright, those points on the left will come here first. Okay, and we'll just move up 1, 2, 3, 4, 5 units, and our second point will be here. Right? Next, we'll move this one up 1, 2, 3, 4, 5 units, and our left side of our graph will look like that. Right? On the right side, we'll do exactly the same. We'll shift our 1, 1 up 5 units. 1, 2, 3, 4, 5. We'll have a point here. and we'll shift our 2, 2 up 5 units, 1, 2, 3, 4, 5, and we'll have a point here. Alright, now let's look at our axis of symmetry. Our axis of symmetry is that vertical line through our vertex. So here, our x is going to equal 0. We get that from here. Right? So our axis of symmetry is x equals 0. Now, notice that that axis of symmetry kind of makes a mirror image. Everything on the left looks exactly like everything on the right. So, if I am 1 unit away from the y-axis on the left, I'll be 1 on the right. If I'm 2 units away on the left, I'll be 2 on the right. 3 on the left, 3 on the right. Okay? Now let's talk about a maximum and a minimum. Here, because we have the lowest value is at our vertex, everything else goes up forever and ever, we have a minimum. We have a value that is the smallest. So we will have a minimum at this point, and it will be whatever our y value is, which is 5. So y equals 5. Okay? Now, what we're going to do next is we're going to look at our domain and range. Remember, the domain are your x values. So here I have every value from negative infinity to 0, and then from 0 to positive infinity, because we stop here and bounce back and head the other direction. So our domain is going to be every value of x, or all reals. Our range, however, is the one that's going to change. Your range is your values on the y-axis. So here, if you notice, I don't have anything below 5. Okay, so here's my 5. I have nothing below that. So my range is going to be everything above 5. So I will write that as y is greater than or equal to, and it can be equal because I actually do have that point on 5. Alright, let's try this one. Here we have y equals the absolute value of x plus 7. So I notice that my h here at 7, it's always going to be the opposite. So my h is going to be negative 7, and my k, since there's nothing here, my k is 0. Since my vertex is hk, I'm simply going to replace it with negative 7 and 0. Okay? My axis of symmetry is going to be that x value, and since x is negative 7, that's my axis of symmetry. My max or min, since this is a positive out in front, I know that it's going to open up, and I know that I'm going to have a minimum value, and my minimum will be whatever that y is. Since y is 0, my minimum is y equals 0. Alright, let's go ahead and graph this guy, and then we'll talk about our domain and range. Start with your parent function here, and let's shift. Since we don't have a k, we're not going to do a shift up or down. However, our h tells us to shift negative 7, which is 7 to the left. So I'm going to take all of my points, and I'm going to shift them 7 units to the left. So starting at my vertex, I will move 1, 2, 3, 4, 5, 6, 7. And notice that's my vertex here, negative 7, 0. My next point, I'll move negative 1, 1 over to the 7 units to the left. 1, 2, 3, 4, 5, 6, 7. And I'll use negative 2, 2, 7 units, 1, 2, 3, 4, 5, 6, 7. And I have the left side of my function. On the right at 1, 1, I will move it 1, 2, 3, 4, 5, 6, 7. I'll move 2, 2, 1, 2, 3, 4, 5, 6, 7. And I can now draw the right side of my function. Go ahead and label your axis of symmetry here through your vertex. And remember, my axis of symmetry is simply x equals whatever that x value is, negative 7. Okay? Alright, let's look at this guy. Here we have a double transformation. We have a horizontal shift and a vertical shift. Alright, so here our h is going to equal negative 3, because remember it's always the opposite, and our k will be negative 6. So our vertex, since it is hk, is going to be negative 3, negative 6. That's going to be my new vertex. All right? So from my parent function, this guy, I'm going to do two transformations. It doesn't matter whether I move horizontally first or vertically. So from my vertex, I'm going to move left 3, 1, 2, 3, and down 6, 1, 2, 3, 4, 5, 6. So my new point, my new vertex, is going to be at negative 3, negative 6 here. I'll now move this point, negative 1, 1, left 3, 1, 2, 3, and down 6, 1, 2, 3, 4, 5, 6. Okay, and I'll move this point, negative 2, 2, to the left, 1, 2, 3, and down 1, 2, 3, 4, 5, 6. I now have the left side of my graph. And to do the right, we'll do the same thing. To the left 3, 1, 2, 3, down 6, 1, 2, 3, 4, 5, 6. And 2, 2, left 3, 1, 2, 3, down 1, 2, 3, 4, 5, 6. And I now have the right side of my function. Let's go ahead and get our axis of symmetry in. Here, right through our vertex. Here's our axis of symmetry. And remember, our axis of symmetry is going to be x equals whatever this x value is. Since x is negative 3, it will be, our axis of symmetry will be x equals negative 3. Right? We have a minimum, of course, because we open up. So this is our minimum value here. And our minimum is going to be y equals negative 6, because that's our minimum value. Whoops. Yikes. Alright, it will be negative 6. Now for our domain and range, our domain, of course, is all reals, and our range is going to be y is greater than or equal to that y value of negative 6. Alright, let's look at this one. Here we have a negative sign out in front, so we know that this is going to be reflected. It's going to open down instead of opening up like it has been before. Let's go ahead and look at our h and k first. Our h is 0 because there's nothing here with x, and our k is going to be 2 because of the number that follows that absolute value. Before we graph this, we're going to go ahead and reflect our parent function first. So here's our parent function. And I want to reflect that first. So if at point 1, 1, I'm 1 unit from the x-axis, so I'll be 1 unit from the x-axis here. We start with the same vertex. From 2, 2, I'm 2 units, so I'll be 2 units below the x. Now I can go ahead and graph the right side of my new function. Okay, over here I'm 1 unit from above, I'll be 1 unit below. 2 units above, 2 units below, and I can go ahead and graph this. Now remember, this is just our reflection. We now have to make that vertical transformation of up 2. So we're going to take every single point and just shift it up 2 units. So from here we'll go up 1, 2, and my new point will be here. From this one, we'll go up 1, 2, from the vertex up 1, 2, from this point up 1, 2, and from this one up 1, 2 here. And our new function looks like this. Okay? Let's not forget to graph our axis of symmetry, and we'll do that where it passes through our vertex. So our axis of symmetry is simply x equals that x value. Our x value is 0, so it will be x equals 0. Now let's go ahead and get all of our important information. Our new vertex in our new function is 0, 2. Remember, it's hk. Our axis of symmetry is just that x value of 0, so x equals 0. We now have a maximum because we have a highest value. Notice everything else is lower or less than this. So we have a maximum of y equals 2. Alright, for our domain, we have all reals. Still we have every number on the x-axis. And for our range, we have y is, now remember when we looked at this, every number was less than this maximum, so it will be y is less than or equal to that y value of 2. For this one, we have a stretch. We actually have that a value out in front now. So what we're going to do to make it easier is we're going to make a table of values. Alright, so we'll have our x's are 3 times that absolute value, and our y. Go ahead and just pick a couple points. Usually -1, 0, and 1 is sufficient. So if we take 3 times the absolute value of -1, remember this becomes positive 1, times 3 will give us 3. Our 3 times the absolute value of 0 is simply going to be 0, and our 3 times the absolute value of 1 is going to be 3. So our ordered pairs are going to be -1, 3, which will put us here. Our vertex 0, 0, which will put us here. And our right side of the graph 1, 3, which will put us here. So this is my new function. Alright, this is just a table for you to view to help you out.